Hey guys, this is Mrs. Harbin, and this is our video for multiplying radicals 3.4, I believe. I don't have the number here on the screen, but I think it was 3.4, and that is multiplying radicals. Our biblical correlation for this radical unit comes from Exodus 31, 2 through 3. And it says, "See, I have chosen Bezalel, son of Uri, the son of Hur, of the tribe of Judah, and I filled him with the Spirit of God, with wisdom, with understanding, with knowledge, and with all kinds of skills." We read all about the importance of gaining knowledge and the importance of gaining wisdom and skills all throughout the Bible. In fact, we see in 2 Peter 1, 5 through 7, because you have these blessings, you should try as much as you can to add to these things, or add these things to your lives. To your faith, add goodness. And to your goodness, add knowledge. And to your knowledge, add self-control. And to your self-control, add the ability to hold on. And to your ability to hold on, add service for God. And to your service for God, add kindness for your brothers and sisters in Christ. And to this kindness, add love. So when we're talking about what God has given us the ability to do and what we are supposed to do with those abilities, we read repeatedly that we're supposed to add knowledge. Not just knowledge, but also service. Knowledge leads to service, and that service should be done in love. And all of this goes back to that creation mandate, that we have been tasked with taking care of God's creation. And we are using our wisdom and our knowledge and our service and our understanding for that one purpose. So as you guys are learning about radicals, don't forget, this is not just important to pass the class. You're learning foundational pieces because one day you may be called to a career that requires you to use these skills in order to serve others. Our lesson objective for today is that you, the student, will multiply radical expressions and simplify when possible. Now, this is a really lengthy presentation. I'm going to try and go through it as fast as I can to get it all in one video. But if I can't do it, just be aware there may be a part 2. Also, if I'm going too fast for you, don't forget that you can pause, go back and rewatch anything that you're really struggling with. But I am going to try to move through this quickly. All right, so our lesson opener says, use the product property to write each radical as the product of the square root of a perfect square and another square root. So we've been working on prime factorization in order to simplify our radicals, and that's absolutely one way that you can do it. But another way that you can do that is writing each radical, looking at the radicand there and thinking about two numbers, two factors that when multiplied equal that number. And one of this might be a perfect square. So let's look at the number 12. When I think about the factors of 12, I know 12 and 1, 6 and 2, 3 and 4. And when I look at those factors, one of those is a perfect square. 4 is a perfect square. So I'm going to rewrite the square root of 12 as the square root of 4 times the square root of 3. I'm going to split it into its two factors. The square root of 4 is just 2. So I can simplify that as 2 and then square root of 3. We don't have to write that times symbol. Just having those two things right next to each other implies multiplication. So I can just simplify that as 2 square root of 3. When I think about the factors of 18, I know 18 and 1, 9 and 2, 6 and 3. And of those factors, 9 is the perfect square. So I'm going to rewrite that one as the square root of 9 times the square root of 2. Or square root of 9 is just 3. So this one can be simplified as 3 square root of 2. All right, try these on your own. Pause the video, try it on your own, and come back and check your work when you think you have it done. The square root of 50 can be rewritten as the square root of 25 times the square root of 2. We wrote it that way because 25 is a perfect square, so if we were to simplify that even more, we would get 5 square root of 2, since the square root of 25 is 5. The square root of 75 can be rewritten as square root of 25 times the square root of 3. Again, 25 is a perfect square, so we can write that as 5 square root of 3. Remember, right next to each other, the implied operation here is multiplication because our radical symbol acts like a grouping symbol in this case, like parentheses or brackets. All right, what about 245? 245. We can write that one as the square root of 49 times the square root of 5, which simplifies to 7 square root of 5, since the square root of 49 is 7. All right, so our product property of radicals says this. For all numbers where x is greater than 0 and y is greater than or equal to 0, the square root, or the root, may not be the square. That n is our index, and the index can be something different. So the root of x times the root of y is the same thing as the root of x times y. So I took my two different things that I was multiplying, and I can just put them both under one radical symbol. Please notice that when you are doing this our indexes do have to be the same. The radians can be different, but the indexes must be the same. So let's try some of these with numbers using this definition. Let's start with root 3 times root 6. Now, the index for both of these is the same. Okay, even though it's not there, we know it's the square root of 3 times the square root of 6. We can write that as one thing, the square root of 3 times 6. Now, we can then multiply and then prime factor, or we can just go ahead and write the prime factors of each of these numbers. So we're going to write the prime factorization of 3 is 3, and the prime factorization of 6 is 3 times 2. And from here, we can then follow our steps that we've been following to pull out all the numbers that we can pull out and leave numbers under the radical symbol. And what we end up with is 3 root 2. Now, we've been doing it by grouping, circling. We've got 2 3's here, so the 3 comes out and the 2 stays under. You're going to see some examples that look a little bit different from how we've been doing it. There are multiple ways that you can go about writing out the simplification process. So if you are good with the one that looks like this, keep doing it this way. If you like the way that you're about to see next better, you can do it that way. All right, root 2 times root 6. The indexes are the same, so we can multiply them. Put them all under one radical symbol, 2 times 6, which this skips here, 2 times 6. And then we go into the prime factorization. Here's prime factorization of 2, and here's the prime factorization of 6. Notice there's not a multiplication symbol here, but there are parentheses, and parentheses mean we multiply. So this is 2 times 2 times 3. We could write that as 2 squared times the square root of 2 squared times the square root of 3. Or if you just want to circle and pull out like we've been doing, you can do it that way as well. But what we end up with is 2 square root of 3. All right, try this one on your own. All right, hopefully you wrestled with that one a little bit. We've made the comparison before. If you're not sure what to do with radicals, think of these radical symbols kind of like exponents. So if this was negative 2x and this was 5y, what would you do? Well, you would multiply the 5 and the negative 2, and you would multiply the x and the y. We're going to do the same thing. The numbers that are on the outside we will multiply, and then the numbers that are under the radical symbols, we will multiply those together. And so what we end up with is negative 2 times 5 on the outside. Here it is. And square root of 18 times square root of 50 over here being multiplied together. Negative 2 times 5 is negative 10. And what you see between this step and this step is prime factorization, and then they've already grouped the numbers before together. So they are, in this example, not writing out that prime factorization, but that's what's happened. And when they did the prime factorization, they ended up with 2 2's, 2 3's, 3 squared is just 2 3's, and 2 5's. That's what they ended up with. So each of those then will come out. If we were circling those groups, we would have 2 2's, 2 3's, 2 5's. So negative 10 times 2 times 3 times 5 gives us negative 300. Right, here's another one. Try this one. Again, we're going to multiply everything under the radical symbols together because they do have the same index. So when we write that, we have 6 times 2, or the prime factorization of 6 is 3 and 2. And then we have our A, and we have our 2 B's here, and then we have 1 C. Let's circle our groups of 2. We have 2 2's. We have 2 B's, so both of those are going to come out. So we have a 2B on the outside of our radical symbol, and what's left is 3AC under the square root symbol. When multiplying radicals, remember to apply the product property. Write the radicand as the product of its prime factors. Then simplify the root of each perfect power, and simplify the resulting expression. So let's try this one, the cubed root of 225 times the cubed root of 315. Again, we can multiply these because they do have the same index. So we can rewrite that as a cubed root of 225 times 315. What's happened here is the prime factorization. So when you do the prime factorization of 225, you get 3 times 3 times 5 times 5. This is just rewritten with exponents. We don't write it with exponents. It's going to look like this, 3 times 3 times 5 times 5. And the prime factorization of 315 is 3 times 3 times 5 times 7. or 3 squared times 5 times 7. Now, we are looking at the cubed root, so this time we're looking for groups of 3 to come out. So if you look at it, I do have 3 5s, so a 5 will come out. I have 3 3s, here's my group of 3, so those will come out, and what will be left underneath is a 3 and a 7. So the 3 times 5 comes out, and the 3 times 7 stays underneath, and we're left with 15 cubed root of 21. More complicated expressions involving radicals can also be simplified using the product property by applying other previously established principles, like the distributive property and FOILing, first, outside, inside, last. Let's try one with the distributive property. Now, we cannot subtract these two terms, even though there's a subtraction sign, because they are not like terms. We have a root 3 and a 2. Can't subtract those. However, if you notice, we've got these parentheses and a number on the outside. So what we can do is distribute the square root of 5 to get rid of those parentheses. So we take the square root of 5 times the square root of 3, which gives the square root of 15. And the square root of 5 times 2 gives us, or times negative 2 gives us minus 2 square root of 5. Okay, that's as simple as that gets. We cannot simplify that square root of 15 anymore. So that is the final answer, as simplified as it gets. Okay, let's try this one. 2 square root of 6 times square root of 15 minus 3 square root of 10. Again, we can't actually add these because the radicands are not the same, so we can't add or subtract them. They have to have identical radicands to add or subtract. However, we can multiply. The only thing that has to be the same to multiply is the index. And all of these have an index of 2. So we can multiply using the distributive property. And when we do that on this particular example, we get 2 times the square root of 6 times 15, which is written out in prime numbers here. And 2 times negative 3 gives us the negative 6. And square root of 6 times the square root of 10 is written out here in prime numbers. We're then going to simplify that. So I've got 2 3s here, so that will come out. And then I've got 2 2s, so those will come out. And what I end up with is a 2 times 3 times the square root of 2 and 5. That's my first term. And my second term is negative 6 times 2, and then under the radical symbol, 3 times 5. The final answer then is 6 square root of 10 times 12 square root of 15. All right, these are going to be a little bit more complicated. So try these on your own, pause it, and then come and check your answers. Negative 4 square root of 24 times 6 square root of 3. And hopefully you ended up with 144 square root of 2. Pause the video and look at each of these steps if you're not sure how we ended up there. Okay, try these on your own, pause the video, and then come to check your work. And if you have questions about any of those examples, be sure to ask in class because the steps are not shown here. Okay, now it's going to get a little more involved. Now we're going to multiply binomials that have square roots or have roots in them. When we're multiplying binomials, remember that we need to use FOIL. First, outer, inner, last. That means we're going to multiply the first term in each set of parentheses, then the outside terms, the outermost ones, then the innermost terms, and then the last term. So we're going to end up with 4 different multiplication problems here before we start simplifying. So we have the first term, 7 times 5, the outer terms, 7 times root 3, the inner terms, 5 times root 2, and the last terms, root 2 times root 3. From there we simplify like we've been doing. 35 plus 7 root 3 minus 5 root 2 minus the square root of 6. There are no like terms because none of these have the exact same variable or being raised to the exact same exponent. They don't have like radicands, so we are finished. All right, try this one on your own. Pause the video and then come check your work. Final answer is there for you. If you have any questions about how we reached that final answer, be sure to ask in the class. Today, we multiplied radical expressions and simplified when possible. If you guys have any questions, be sure to ask me next class.